As of now, what is the state of a tuple? How many tuples do we have in the student table? That represents the relational instant. Explain, or in order to describe the structure of a database, then we call that as a relation schema. So here what and all should be considered? I should consider a name of a table and the attributes along with its name. Together we can call this as a relational schema. Whenever we are entering a value, order does not matter, but the value what and all we are giving that should be associated with its attributes. Hello everybody, a warm welcome to one and all. Welcome back to the session 1 of chapter 1 in the unit 2 of B.Ca's third semester subject called Database Management System. In short, it is Dbms. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we are learning with our unit 2 in that chapter 1. That's all regarding what? Relational data model. So we'll see in our today's session, we're going to learn about this relational model concepts. First, we will get to know what is relational data model and what are the different concepts we have in it. Along with that, I will be discussing what are the characteristics we have with respect to this relation, and then what are the relational model constraints. So you will get to know what is this constraint and what are the different types of constraints we have along with the example. That is what I will be discussing in my today's session. Let me get into it. First, we'll see what do you mean by this relational model. First, we are learning with relational model concept. In order to understand that, first we should understand what this relational model is all about. So, it represents the database as a collection of relation. So, what we are doing here, already you know about the schema. We are using different collection of data models, or we are using different methods in order to represent the database. Here also, we are using this relational model in order to represent the database. In which term we are representing it? With the help of this relations. Then what do you call this relation is as? It is also considered as what? Tables of values. If I say table, then what table consists of? Table will going to have rows as well as the columns, correct? So every row in the table represents a collection of related data values. Moreover, we are representing the database with the help of this table. If it is a table, then it will be a collection of columns as well as the rows. Here all you can see here, all these are rows. So these are the columns, correct? So in this, row will going to be used in order to represent the collection of related data values. We are using this rows or a tuples or a record in order to give the related data values. And in this rows, the table denote a real world entity or relationships. So here we are using this tuple or a rows in order to represent the real world entity. If I take an example of student, then it comprises of what? Student ID will be there, student name will be there, their age will be there. So here I am going to write 1, 2, 3 and name will be ABC and age will be 18, 19 and 19. So all these are what? That representing the data values. Then we say that as a rows or a tuples or a record of a relation. So that the table name and column names are going to be helpful in order to interpret the meaning of values in each row. So here, as I told earlier, I am just going to take the table name as student, and with the student name of a table, the table name is student, and I have certain column called student ID, name and age. So if I consider this table name along with this column name, that will going to be helpful in order to understand or to have the meaningful value to the rows. So I will get to know, yes, this is a student table, this comprises of student ID, name, age. I have to give a value which is related to all these entity or a real world object. For that concept we are using this relational model, so that the data are represented as a set of relations. So here we are having a collection of table. If it is a collection of table, then that is a relation or a set of relation that is used in order to represent the database. So that in the relational model, data are stored as table. However, the physical storage of the data is independent of the way the data are logically organized. So here we are giving a weightage for the virtual storage of data, that too in the terms of table or a relation. This is what you have to understand when it comes to the relational model. Fine. So now we'll see some of the relational model concept. Whenever we are working with this collection of records or collection of relations, or in order to represent the database, we are using certain terminologies here. That is what we have to understand right now. First, what we have? Table. As I told earlier, table is also considered as a relation here. So that in the relational data model, relations are saved in the format of table. If it is a table, obviously it has to be consist of rows as well as the column. So this format stores the relation among the entities. So we are going to use this table in order to store the content with respect to an entity. So table has rows and column, and we calling this row as a tuple or a record, and also we are calling this column as what? Attributes or a, we are calling that as a domain. Okay, you will, as of now you understand, we have a table that has rows. Rows represents what? Tuple, and this column represents the attribute. If I take the example of this student is the name of a table, and how many columns do I have here? 3. That is what? Student ID, name and age. So all these are the tuples. So we have 3 tuples and we have 3 columns or attributes for a table called student here. Let me move to the next concept, that is what? Tuple. So you already got to know the meaning of tuple. So a single row of a table which contains a single record for that relation, then we call that as a tuple here. Okay. Then what is this relational instance? So instance always specifies the current state. Okay. So the finite set of tuples in the relational database system represents the relational instant. For example, if you take the student example again, that comprises of student ID, name will be there, and age. So let me consider 1, 2, 3, and here we have a name ABC and 18, 19, 19. So as of now, what is the state of a tuple? How many tuples do we have in the student table? That represents the relational instant. Finite set of tuples in the relational database system represents the relation instance. If I remove this third tuple, then as of now the relational instance is only 2. That means how many number of tuples do we have as of now for the current state, that represented by this relational instance. Then we have this relational instance do not have duplicate tuples. I can't have a same value for all the attribute in both the tuples or both the records. So this has to be unique from one tuple to another tuple. Then we can say that what? There is no duplicacy. In order to maintain the consistency of your data, there should be no duplication in the number of tuples. The value of tuple should be unique. We'll see the next concept here, that is relation schema. What this relation schema represent? A relation schema describes the relation name, that means table name, and attributes and their name. Then we call that as a relation schema. The concept which we are using in order to explain or in order to describe the structure of a database, then we call that as a relation schema. So here what and all should be considered? I should consider a name of a table and the attributes along with its name. Together we can call this as a relational schema. Fine. We'll see the next concept. Here we have a relation key. As you all know that we have a table, in that rows and columns we have. Then how can I find the uniqueness of each tuple? How can I find the uniqueness in each record? Then we are going to use this relation key. Is the key of every door is same? No, right? We have a uniqueness in key. So that means in order to identify the uniqueness of each rows in a table, then we are going to use this relation key. So each row has one or more attributes known as relation key, which can identify the row in the relation table uniquely. Let me consider the same example again. Let me consider student ID and name will be there, as well as we have a age here 1, 2 and AB, and let me consider 18, 18. If you see here, the age of two tuples are same, but how can I find the age of this name called B? By their student ID. Why? Because student ID will going to be unique for each student. There we can't have a duplication or redundancy. So I am going to take this column student ID as a relational key. That means with the help of this attribute, I am finding the uniqueness of the tuples in a relation. Then we call that as what? Relation key here. Then what about this degree? The total number of attributes which in the relation is called the degree of the relation. Then what is the degree of relation in this table called student? That is 3. Why? Because I have 3 columns, student ID, name as well as the age. This is what specifies the degree of a table. Then what about this cardinality? Degree is related to attributes and cardinality related to rows here. So the total number of rows represents in the table will be considered as what? Cardinality. Then what is the cardinality of this table? That is 2. Why? Because we have 2 rows here. We'll see the next concept. Attribute domain. Every attribute some predefined value scope known as attribute domain. That means that represents what kind of value it will going to hold. For example, student ID. Let me consider this as varchar data type. That means it can have both character or alphabets along with the numbers. But if you consider this age, I can't give this varchar. So it's supposed to be integer. Then that represents the attribute domain. What kind of values it will going to hold. That moreover concerned regarding the data type of that particular attribute. So all these are what? Relational model concepts. We'll see the next concept, that is characteristics of relation. As of now you got to know what is table, what is relation or relational instance, key, tuple, cardinality, domain, all the concepts that and all you got to know. So as of now we're going to discuss what are the different characteristics we have with respect to this relation. What is the first characteristics in that? Ordering of tuples in a relation. Then how the ordering of tuples should be. For example, you just imagine, let me consider the same example again. Here we have student table, in that we had student ID and then name. After that we have this age column, correct? And here in the earlier example, as you all see that I had taken 1 and 2. But now I am going to give student ID 2 as first value and student ID 1 as next value. So it was like this, correct? So here the ordering of tuples in a relation does not matter. Whether you are taking second student ID next, that does not matter. What is the main thing? The value should be there in that particular tuple. So that is what you need to understand. Ordering of a tuples in a relation does not matter. So here we mainly concentrate related to what is the attribute and what is its associated value. We won't bother regarding the value or the order in which we are giving the value to a tuple. What is the next point? Ordering of values within a tuple and an alternative definition of a relation. What it means here? Whenever we are entering a value, order does not matter, but the value what and all we are giving, that should be associated with its attribute. So here we are calling that as a pair, attribute along with the values. So here I can't take 18B then 2. Why? Because the ordering will going to be, ordering of attribute will going to be different. If I give 18, that 18 will going to be stored as a student ID, not as an age. So if I give B, that will be in the name. If I give 2, that will be considered as age. So that the ordering which and all we are giving in the tuple should be alternative to the attribute. Then only we can consider that as a proper value that we are giving. So here an alternative definition of a relation. We should understand what is the name of a table and how many column we have, what must be the kind of value it is going to take. And also you need to concentrate on the number of values. For example, if I have 3 column, then the number of values should be 3 only. It can't be more than that. So if it is lesser than the attribute value, then that will going to be assigned as what? Not known, or the value will going to be considered as 0 itself. So that is what second characteristics you need to remember. We'll see the next characteristics here. Values and nulls in the tuple. So how we are supposed to treat the values as well as the null values in the tuple. So what and all value that we are giving should be what? Atomic in nature. That should not be further dividable into any other value. It should be the utmost last value. So that is what? The value should be atomic in nature. I can't further divide that. If you consider name, that name should be what? Only whole value. I can't consider that as what? First name, middle name or last name like that. If it is that, then that is composite attribute. The value which and all we are giving in a tuple should be a single value, or it should be atomic in nature. And also you should treat the null in a special format. So that null value can be what? Missing value, not known value, or it is not going to be applicable value. So in the example of student, if I am considering the age as null, then I should treat this null in a proper way. So that means what? In the student table, if I am considering null as a missing value, in the same way I should use that null as a missing value in another table as well. So in one table I can't consider this as a missing value of null, and in another table I can't consider the null as a not applicable value. In another table I can't consider that as what? Deleted value, like that. So if I am considering the null as a missing value throughout the table, I have to maintain the same thing. If I am using a null for a not applicable value, then we have to use that null as a not applicable value throughout that database. So we should treat the null values and atomic values in a proper way. That is also one of the characteristics here. Then what we have here? Interpretation or meaning of a relation. Simply, if I am calling this as a student table, then it will comprises of what? Certain column like student ID, name and age. Then there must be some interpretation or meaning. We have to take the name in the real world object that exists. We have a physical existence or virtual existence, but that has to be there. So whatever the values or whatever the attribute names along with the table name which and all we are giving, that must have certain meaningful. So if you consider this student, the name of a table is what? Student. If it is the name of a table is student, then that must include a values or attribute which will going to explain the entity called student. So here I can't store the details of books. Why? Because that books values what and all we have, that does not will going to match with the student value. So that we should have a proper interpretation or meaning of a relation. Then we are going to specify the meaning of a relation with table name and its attributes name along with the values which should be associated with the attributes. So all these are considered as what? Characteristics of relation. The ordering of tuple does not matter, and the ordering of values which and all we are giving should be associated with attribute along with a value, and then we should have a proper interpretation of values as well as null. The value should be atomic and null values should be treated in a special way. It can be missing value, deleted value, or it can be not applicable value. And interpretation or meaning of a relation should be proper. So all these are relation characteristics of relation here. We'll see the next concept, that is what? Relational model constraints. So now we got to know what is relation and how it's supposed to be. Whenever we are transmitting the data from one table to another table, whenever we are sharing it, or whenever we have concurrent execution, number of users will going to use the database as well as the collection of tables. So we should limit the number of usage. We should give certain restriction in order to use that. Then we call that restriction as what? Constraints here. So every relation has some conditions. We must put certain conditions or limits here that must hold for it to be a valid relation. If I wanted to consider any of the relation as a valid relation, then that has to hold certain condition which will going to be specified as a constraints here. Then what are the different categories we have in this constraint? It is comprises of three main categories here. See, the constraints that are applied in the data model. So, the constraints which we are applying to the data model, then we say that as a implicit constraint. Whenever we are having certain conditions or restriction over the data model, then we call that as a implicit constraint. Then next type is what? Constraints that are directly applied in the schemas of the data model by specifying them in the DDL or a data definition language. Then we call that as a schema based constraint, and also we call that as a explicit constraints here. So if you are applying the constraint to the data model, then that is implicit. If you are applying the constraint to the schema or a skeleton representation of a data model, then we call that as what? Schema based constraint or explicit constraint. The constraint which we cannot apply, then we call what it is as constraint that cannot be directly applied in the schemas of the data model, then we call that as a application based or semantic constraint. If it is applied on a data model, implicit. If it is applied on a schema, explicit. If it can't be applied on a schema, then we call that as a application based or semantic constraint. Again, this explicit or schema based constraint will going to be divided into 4 types, that is domain constraint, key constraint, entity integrity constraint, and at last we have referential integrity constraint. Domain, key, entity integrity constraint, and we have referential integrity constraint. We'll see each type. In that first what we have? Domain constraint. Already you know the definition of domain. That represents what? Columns, right? Then how kind or what kind of constraint or a condition that we can give on the column? Can I have a same name of column twice or thrice in a same table? No, right? If I call student as a table, that must be what? Should have a unique column name. Here I can't have student ID, name, age. Again I can't take name. Why? Because these two columns specify a same name. And what is the next constraint we can have? We can give the constraint based on the data type. For example, for age, if the data type is integer, then whatever the value that we are giving should be only numbers or integer. It should not accept any value other than the integer. Then we say that as what? Domain constraints here. So can be defined as the definition of a valid set of values for an attribute. Whatever the value that we are giving to an attribute should be a valid set of value. Then we can say that as a domain constraint. Mainly the value of each attribute must be an atomic value. The main constraint is what in the domain constraint? The value of any of the attribute in a table should be atomic in nature. So here I can't take 18, 20. Can a person have two age at the same time? No, right? So it can't be multiple values or composite value. It should be atomic value. That is also one of the constraint here. And the data type of domain includes string, character, integer, time, date, and we have currency here. As I told earlier, if I am considering this age as an integer data type, then it has to accept only integer value. Other than that, it should not accept any kind of values. That is what you need to remember. So that the value of attribute must be available in the corresponding domain. If I say the student ID, that should be associated with this student ID attribute. What do you mean by this domain constraint? The data type should be considered and it should be atomic value. It should not be multiple values. Here you have the example. Let me consider this as a student itself. In that consists of student ID, name, semester and age. So here you can see that what are the different constraints we have in a domain. The name of a column should be unique. So here I have ID, name, semester, age. No problem. But in this domain constraint, here you can see that we have a age attribute here and mentioned as a integer data type. So all these we have 17, 24, 21, 19. But here I have a A. A is what? Character or alphabet. That has to be in the type of varchar. It can't be accepted or not allowed. Why? Because age is considered as an integer attribute. And also if you consider this, I can't have one more value for this. So that is also specifies this domain constraint. Fine. Here you can see the second constraint, that is what? Key constraints or uniqueness constraints. Already you know the meaning of key. So which we are using, collection of attributes or an attribute which we are using in order to find the uniqueness of a tuple. For that we have this key constraint. So we'll see. So this is also considered as what? Uniqueness constraint. Why? Because every tuple in the relation should be unique. So I can't have a duplication in the tuple. That represents what? Uniqueness constraint. And keys are the entity set that is used to identify an entity with an entity set uniquely. So if I wanted to find out the entity in an entity set, then we are going to use this key. An entity set can have multiple keys, but out of which one key will be considered as a primary key. So here we are using a primary key constraint. If it is a primary key, if I am making any of the column as a primary key, then that should contain a unique value and the value should not be null. So not null values will not going to be accepted for this primary key constraint. The value should be unique and it should not be null. Then those two are the constraint which we have for this key constraints or uniqueness constraint. So here you can see that here it has to satisfy two conditions. Two distinct tuple in any state of the relation cannot have identical values for all the attributes in the key. For example, if you consider the student ID and name. So this can't be allowed for the relation here. Why? Because as per the key constraint, two distinct tuple in any state of the relation cannot have identical value for all the attributes in a relation. So if it is 2, then we can consider. Why? Because the values are different. But the identical values of all the rows, all the tuples in a relation is not allowed as per this key constraint. And it has to be a minimal super key, that is a super key from which we cannot remove any of the attributes and still have the uniqueness constraint in the condition 1 supposed to be hold. So what it means, if you consider the student ID, student name and student age will be there, and it is also going to include the phone number. Okay, so student will going to have all these attributes. If you consider the student ID, this uniquely used in our as a primary key, correct? So by making use of this primary key, I can have the uniqueness in the tuple. So if it is a collection of phone number and student ID, then that will be more unique. Then we can say this as a candidate key. Collection of one or more tuple which is enforcing the uniqueness of a tuple more precisely than the primary key, then we call that as a candidate key. We can have any of the collection. I can have a collection of student ID along with a name. Then also I can call that as a candidate key 2. And I can also take student ID, name and age. Then I can call that as a candidate key 3. Correct? So the collection of all the candidate key will be considered as what? Super key. In order to hold this key constraint, then it has to be a minimal super key. If it must have one or more attribute in order to have a uniqueness. This represents what? Key constraints or uniqueness constraint. We'll see the content with respect to this key constraint itself. A relation can have multiple keys or candidate keys. As I told earlier, it can have more than one candidate key, out of which we choose one of the key as a primary key. So I am not taking more attribute for a primary key. Out of that candidate key, we are choosing one of the attribute for primary key. We do not have any restriction on choosing the primary key out of the candidate key, but it suggests to go with the candidate keys with less number of attribute. Instead of taking 5 attributes as a one candidate key, then we have to make a separation as 3 attributes as one candidate key, another 2 attributes as another candidate key. And whenever we are having this key constraint or uniqueness constraint, at the time null values are not at all allowed in the primary key. So that here also you can see that we have this not null constraint. It's also a part of this key constraint. Whenever we are having this key constraint, we are using a concept called primary key. If it is a primary key, then it should be unique and the value should not be null. So should not be null in the sense what? We are also enforcing not null constraint here. The value should not be null. Why? Because we are using primary key in order to identify the uniqueness. If it is a null, then we can't find out the uniqueness. So it should not be null. You can see the example here. Here we have 1000, 1001, 2, 3. Again here I have 1001 and name Johnson, and second all the values are same. As we told earlier, in order to satisfy this key constraint, if it is a primary key, if it is need to be satisfied, no two tuples can have a same or identical value for all the attribute in the table, then that can't be considered. So this is not allowed. Why? Because all the rows or tuple value must be unique, and it can't be null also. If it is null, you just imagine there is no value for this 1003 as a value for this ID. So even this is also not used or not considered. Why? Because it should not be null. This is what key constraints or uniqueness constraint. Next what? Here we have integrity constraint. Why do we require integrity constraint? Mainly to have a consistency of a data. The quality of information should be maintained in a table or a database. For that reason, we have this integrity constraint. So it will going to ensure that data insertion, updation and other process have to be performed in such a way that data integrity does not affected. You should not change the purity of a data. You should not decrease the quality of an information. Then we call that kind of restrictions or conditions as what? Integrity constraint here. Mainly it is used to guard against accidental damage to the database. Moreover, we are using this integrity constraint in order to maintain the consistency and quality of an information here. So in that, first we have a entity integrity constraint. What do you mean by it? It says that no primary key can take null value. So we are using primary key to identify each tuple uniquely in a relation. In this entity integrity constraint, that specifies that we should not allow any of the null values to the primary key. If I am considering student ID as a primary key, then that student ID should be unique and it should not accept any of the null value. Why? Because we are using primary key itself in order to identify the uniqueness of a tuple, so that it is used to identify the individual rows in a relation, and if the primary key has a null value, then we can't identify those rows uniquely. So that a table can contain null value which is other than primary key. I can give null value for the name, that is not what primary key. Fine. Here you can see the example. Here we have a table called employee, employee ID, name and salary, and this employee ID should be underlined. Why? Because this will going to specify that as a primary key. If it is a primary key, in order to satisfy this entity integrity constraint, it should not be null. So here I can't consider this tuple. Why? Because the value of this primary key is null and it should be unique. So if it is not satisfying, then it is violating this entity integrity constraint. Okay. So it has to be unique and it should not be null. Next, we will have this referential integrity constraint. So, till now we all discussed regarding the constraint within a table. Then, how can I ensure the purity of information or quality of information between the two tables? For that, we have this referential integrity constraint. What it says that constraint is specified between the two relation or a table, and it is used to maintain the consistency among the tuples in two relations. So, if you wanted to maintain a consistency between the two tables, then we should use this referential integrity constraint. Then how do we use it? With the help of foreign key. We are using a concept called foreign key here. By making use of that foreign key concept, we are using this, or we are ensuring this referential integrity constraint. Let me take the example to make you understand here. Let me consider a table called employee. Consider the table called employee. Here it has employee ID and we have name, and consider D number or department number 1A, 1B, and name, let me consider ABC, CDE. After that, here let me consider 11 and 12. Okay. What is the table name I have? I have employee table that comprises of employee ID, name and D number. Let me consider one more table, department. So I will use this as a department number and department name, and also what ID. Fine. Let me consider department number 11, 13, department name CS, bio, and then ID. Let me consider the ID as 100, here 200. Okay. So you just imagine we have an employee table and we have a department table here. So here I am going to call this as a foreign key. Okay. So why? Because the attribute of one table will going to act as a primary key of another table. Then we call that as a foreign key. Whenever you are in India, you are the citizen of India. But when you go to any other country, then you will be considered as what? Foreigner. That means what? You are referencing your identity in another country. So that is what, here we have a department number. That means here we have an employee table, that in that employee table we have a department number. The department number attribute is used in order to refer the department number in the department table. So you just you can see here we have a department number 11 and 12. So this 13 is not allowed. Why? Because this 11 is referring this tuple or having a relationship between the different tuples of two table. This 12 is not exist in this department. So the value of this primary key in the department can be null, but it can't have any other value which does not present in this employee table. So this will be considered as what? Associated value. Then it will be the orphan value. So that whenever you wanted to make sure and this referential integrity, at the time in order to maintain the consistency, whatever the column we are considering as a foreign key, that has to be referred as a primary key in another table. So the value whatever we have for that attribute foreign key can only be present as a value in the primary key of another table. So this 13 can't be referred by this 12. So it will be considered as what? Orphan values or orphan tuple or record. Why? Because this is not referring it. So if you don't have a citizenship of any of the country, then you can't be a foreigner in any other country. Why? Because you don't have the identity at all. The value of this can be null, but it can't have the value which is not in this foreign key. That is what referential integrity constraint. Now you read it, now you can understand. This constraint is enforced through foreign key, where an attribute in the foreign key of a relation R1 have the same domain as the primary key of the relation R2. You can see here, this is relation R1, this is relation R2. That means table 1 and table 2 here. So the foreign key of relation R1 have the same domain as the primary key of relation R2. Then foreign key of R1 is said to reference or refers to the primary key of relation R2. So what it means? So here the D number or a department number is considered as a foreign key of a relation R1 is referring as a primary key of relation R2 department. Then we say that as what? Referential integrity constraint. So that the value of the foreign key in a tuple of relation R1 can either take the values of the primary key for some tuples in the relation R2, or it can be null values but can't be empty. So it can be null value or it should have a value but it can't be empty or any other value which is not in the foreign key value to the which is referring to the primary key of another table. Then this will going to ensure this referential integrity constraint. I hope I made it easy in order to understand this referential integrity constraint for you. I hope you all understood my today's session. In our coming session, we'll start with this chapter 2. That's all regarding what? Relational algebra. Let me meet you there. Until that, keep learning, keep on growing. Thank you.